Good evening, or morning, or something. Welcome to Dark Dragon Does Math. Here is my scale model of what I looked like when I was but a wee dragon. I look like a human now. I'm not sure how that happened, but we're doing another real-life example of a linear graph, and we're going to answer some questions about it. So, a car uses 1 gallon of gas for every 20 miles traveled. The amount of gas left in the gas tank, X gallons, after traveling Y miles is given by the equation Y is equal to 240 minus 20X. Graph the relationship between X and Y. Use 1 unit on the horizontal axis to represent 1 gallon and 1 unit on the vertical axis to represent 20 miles. So I'm going to start off by graphing, and I love that we have this last sentence here. It tells me a lot. It tells me that 1 unit on the horizontal axis, I'll start at 0 here, so every one of these is 1 gallon. It also tells me, since it says gallons, that gallons is going to be the variable down here, but I'll get to that in a second. So every one is 1. So 2, 3, 4, 5, 6, 7, 8, 9. I'll stop counting. Okay. And then it also says that 1 unit on the vertical axis represents 20 miles. So 1 unit here is 20. So every one is 20. So that's 40. We're going to count by 20. 60, 80. Okay, so we have all that. And so now what I'm going to do is I'm going to graph. And I love that they've given me a little table here. Another way, if I didn't know anything, I could plug in values here for X to figure it out, but we're not quite there yet. Well, we can say, okay, so, but we've done in the past. So say I wanted to go 6. I wanted to put in 6 there. I'd say 240 minus 20 times 6. That's equal to 240 minus 20 times 6 is 120. What 240 minus 120 is 120, which we have on this little handy graph down here. 6 gallons would equal 120. So why don't I graph that? As 6 gallons, we're at 120. At 12 gallons, we're at 0, so that's actually the first point down here. At 10 gallons, we're at 40. So 10 gallons, we're at 40. And what's kind of neat about this is if we have this right now, we actually know how the rest of the graph is going to go because all these are linear graphs. So if I could use a straight edge, I could totally just and wherever it crosses, there's our answer. So let's look over here. Let's see, we had 80. I want to fill in this table right here. Oh, and also I want to label it. So amount of gas was X gallons. I know that from right here. And then distance travel, that is Y miles. Alright, so that's where I'm at right now, and let's give it a title. This is a car traveling, so car traveling. And really what's happening is gas left in the tank. So I'll say gas usage or something like that. Okay, so at 80 miles, here's 80, I had 8 gallons left. And what you'll notice is 12 to 10 went down by 2, went down by 2, went down by 2. 160 is probably 4. So 160 is right here. Well, it is 4. Fantastic. So we know we're doing that right. So let's go ahead and add those points on there as well. What type of graph is it? Well, if you don't know by now, pay attention so you never forget. Linear. It's a line. All these graphs are going to be linear. Okay. We have some more questions on the back we want to answer. So, for example, written down. No, I'm just going to have to flip. All right. So, for example, on the back, how many gallons of gas will be left in the tank after the car has traveled 60 miles? So, after 60 miles, how many gallons of gas are in the tank? So, I've done this before. Just look over across from 60 and then go down. The answer is 9. So, so how many gallons are left in the tank after 60 miles? There are 9 gallons left. Another way to do that is to say, okay, so 60 gallons is about right there. What is between these two? All right, between 10 and 8, that's 9. Between 40 and 80 is 60. Between 10 and 8 is 9. So using the table wisely, how many gallons will be left in the tank after the car has traveled 100 miles? So 100. We look at 100, touch the graph, come back down. We're at 7. So after 100 miles, there are 7 gallons left. After the car has traveled 160 miles, how much further can the car travel before it runs out of gas? So this is a little bit more complicated. We want to know how long till it goes down. So if we look closely, let's think about how much it's going down per mile. So if 1 gallon, it uses 1 gallon every 20 miles. So 1 gallon is 20 miles. So if we know 1 gallon is equal to 20 miles, we're at 160 right here. That means we have 1, 2, 3, 4 gallons left in our tank. We have 4 gallons left. Let's figure out how far we can go. So to go from here to here, we multiply by 4. To go from here to here, we multiply by 4. 20 times 4 is 80 miles left. So the answer is 80 miles. Another thing, and it's not a coincidence, is if we look at our graph, what we have here is, see that 240 right there? That's how many total miles we could go on 1 tank of gas. And I know that's not explicitly stated. I'm just trying to show you a pattern here. If we've gone 160 so far, we can see how much would be left to get to 240. Subtract that. 24 minus 16 is 80. There's 80 miles left. Okay. If the car travels more than 40 miles, how much gas is left in the tank? Express your answer in the form of an inequality. So we want to go more than 40. So here's 40 miles. So we're going up from here. And as we go up, our actual gallons go down. See? They're going to go down from 10. So as we travel more, we have less gallons in the tank. So remember, gallons was X, and we want to know how much gas is left. So X will be less than or equal to 10 gallons. Name the independent and dependent variable. So again, independent is here and here. That's X gallons. So independent is equal to X gallons, and dependent is equal to Y miles. All right.